This is my first video of 2023, and what we have here is an unusual sight for my workbench. It is almost completely devoid of projects. Just here we have a 1541 drive casing, which I started making into a housing for my Superboard Pro Disk Flux image copier. That still has a lot of stuff that needs done to it. There's parts for that in that cardboard box right here. Sitting on top of that cardboard box is an NEC PC-8201A that has been sitting there a couple years at least. I started taking it apart and got interrupted and got interrupted and got interrupted, and I have no idea if it worked, what I was going to do to it, etc. So that is going to be the subject of this video. We are trying to get the next to the last repair project, or project in general, I guess, off of the bench before we start a whole host of new projects for 2023. And eventually, once I figure out where I stopped on this 1541 deal here, we'll get to that as well. So let's jump right in. Thanks to PCBWay for sponsoring this episode. They offer an excellent quick-turn PCB prototyping service, which now has a free upgrade to the 150-160 temperature range. They also offer a wide range of services that allow you to go from idea to a finished product, including CNC machining, 3D printing, injection molding, PCB assembly. Go on over to PCBWay.com/OEM to find out more. I have retrieved our pile of PC-8201A stuff from the corner of the bench, and let's see what we have here. That is an SX64 keyboard cable. That is not related to this, so we will put it back. And this all looks like PC-8201A stuff. Have a new memory battery, so I am guessing I was going to install this into here. The original NEC branded power adapter. A baggie of screws. There are 4 screws, so that's probably for the case. An 8200 series personal application kit. Cassette tape. It has a terminal program and music and some games and some other stuff on there. I'll have to look at that. We have 2 battery cassettes. These things, you put your batteries in, you can jumper this for using rechargeable batteries. And then this plugs into the side of the machine. There were 2 of those that came with this. This one is heavy, it's got something in it. It's got some old NiCads in there. 2800 milliamp hour NiCads. Well, these might not be so old. That's a rather big NiCad value. Generally, back in this time frame, you would have like 600, 800 milliamp hour cells. So, and these are not really corroded. I have to check how these jumpers should be set here. There's like a resistor that you change for using NiCad cells. So, I'll have to see. Maybe those are actually good cells in there. And here we have the computer. Okay, well, the case has definitely been taken off. We've got dust and fuzzies on the case, but otherwise it's in good shape. There is something inside. PC-8201A battery cartridge instruction guide. Okay. And it comes the other way, Jeffrey. And here's our computer. Well, it looks okay. It is a little dirty, but not in bad shape. Didn't even have to take the cover screws out. And the keyboard looks okay. This doesn't look like the foam has degraded. You guys have seen I've done a video where this foam in here is degraded and just made a royal mess out of everything. Since we're going to work on this anyhow, we'll go ahead and pull the LCD out to check that foam, because I would rather replace it now before it gets really, really bad. That was a real mess last time. Okay, and here we have the computer itself. So this is missing the screw that held the power supply in. I kind of vaguely remember now taking this power supply out to compare it to another power supply I was working on. Now these look like original capacitors, and these two have a tendency to leak here in this section, and we have the original Yesua battery. Oh, it's not a Yesua. Yeah, that's a Yesua. Or Yusa, or something like that. I don't know how it's pronounced. At any rate, it does need a memory battery replaced. We'll need to check the capacitors here because they do leak. The rest of the caps on this board are okay. Most of them are tantalums. There's a few non-polarized here, but these really don't leak. But we may go ahead and recap the power supply, because that generally gets eaten up in this area and sometimes here. So you can see this is where the battery cassette plugs in, and that looks okay. It doesn't look like it's had corroded batteries in it. This must have been owned by Neho Marketing. Oh, look at that. It's been so lovingly used that the paint has worn off the front here, that brown stripe. You can kind of see what it did look like there. Yeah, that's just from typing, having your hand sitting there. I bet that would be really difficult to color match. And on the back here, it has some text silk screened, so you couldn't paint it all the way around. You would have to maybe just do the front, which is where it looks like it's the worst. And, oh yeah, looky there. Metropolitan Insurance Company ROM. And the full complement of RAM modules. Two stock ones, and it's full of add-ons. And this is the basic ROM. This is a custom ROM from the insurance company. Okay, so yeah, those feet are rather smashed down. Kind of chipped. They've gone hard over the years. I'm not sure if we can get those feet popped out of there. That's not a big deal there. Okay, so what should we do first? I guess we will disconnect the power supply and pull the main board out. Make sure it looks okay. I don't think we really need to do anything to it. Or, you know, maybe we should just start from basics. We'll plug the keyboard LCD unit into here and power it up and just see if it works first. Yeah, let's go ahead and do that. Okay, I've got the bench power supply running. It is set to 8 volts, which is its maximum voltage, current limited to 300 milliamps. This thing shouldn't draw anything close to that. And we've got it plugged in here. It's a center negative. And the power switch is here. I went ahead and plugged the speaker in too, so we should be able to hear the speaker click on power up even if the LCD does not come on. Hey, look at that. Nice. Shows the full complement of RAM. And let's try the contrast wheel here. Yeah, we've got good contrast. And yeah. So our power supply is doing good. I'm going to basic. 10. Print. Everybody's favorite test program, I'm sure. Hey. All right. Well, so I guess what we need to do is clean this guy up and recap the power supply, replace the memory battery, and when I had the cover set up like this, and I was kind of looking at an oblique angle on the screen, I can see some crumbles under here, so that foam in there might be starting to break down. So we'll definitely want to look at that and replace that foam if it is indeed getting crumbly. We might start with that. Okay, let's see here. I think there's just a screw in each corner. This LCD is essentially the same as the Model 100. I think on one of them the low battery LED is round, on the other one it's rectangular. If memory serves, that is the difference. Okay. Yes, we do have some crumbly bits on the LCD. Yeah, this one's rectangular, so the Model 100 is round. This doesn't look corroded like we've had a battery problem in the past. And yeah, you see the crumbles that came off of there? Okay, so we caught this one before it was a disaster. So I'm going to change screwdrivers. This one doesn't fit these screws very well. I'm going to pull the keyboard out so we can get to this foam and get it off of there. And I think I've got some other foam on hand that I used on another one of these that we can reapply there and get that fixed up. If this starts crumbling, it will get into the LCD all over the place. It gets into the keyboard. It is a real mess. So it's a good thing to check on these. So I got the keyboard out, and the last one of these I did, it was really a pain getting all the goo that was left over from the foam off of the clear plastic. So I put some blue painter's tape on there, and then I had an idea. Take a little piece of painter's tape like this, put over the foam, press down hard, and look at that. You can peel up the majority of the foam without it making a crumbly mess everywhere. I suppose you could even use a tool like that to press a little firmer. Oh yeah, so we got most of the crumbly stuff off of there. I'm going to take some alcohol, just a bit, on a Q-tip. I'm going to try to scrape that off of that edge, because any liquid over this edge will kind of seep down between the plastic and the case, and we don't want that. Okay. And we can just go over this a bit with the alcohol. I don't have a lot of alcohol on here because I don't want it to run. That will just loosen up the sticky stuff. Pick the crumblies off there, but you get the idea. So using the tape to peel off most of the crumbly stuff is a big help. See, the alcohol was on there for less than a minute, and now we can get most of that right off of there. Much less mess than the first one of these I did. Much less mess. Okay, so I'll do the rest of this, getting this foam junk off of here, and then we'll put some new foam on. I wound up giving both case halves a wash in the sink, blew it off with the air compressor, let it dry overnight to make sure it is nice and dry. I used the Novus plastic polish to polish a few minor scratches out of the outer plastic screen cover, and then wipe down both halves of the case with the 303 aerospace protectant. It came out pretty good. It looks pretty nice. There is some wear along this edge of the case almost in a straight line. So I don't know if they had slid this into something or what the deal was there, but it's kind of odd. It's like rubbed so much it's worn the texture off just right there. But it's in pretty good shape overall, other than the paint wearing off as we saw here. So now I've got some strips of foam rubber cut off that we can place on the inside of the plastic. That is from this stuff right here. I bought this roll a few years ago off of eBay or Amazon. I've got the link to all this stuff in the description down below. Folks always ask for it, so you can find the links there. All right, so now let's get those foam strips put on there. Okay, I've got this sitting on a rag. Since I've already polished the outside of the screen, I've cleaned the inside here too. And I've got an 8mm wide strip of this foam cut. I think maybe we'll try to cut it to length before trying to put it down. And I might need to cut one more piece. I don't know if 2 strips of this is going to be enough. I think they did this just to keep dust from getting up between the LCD screen and the inside of the plastic, which was, you know, a nice touch. So, peel back about an inch there, or 25-30mm for you people doomed to use the metric system. Yes, that's a joke. No hate mail. This stuff's a little springy, so I'm trying not to stretch it. So I'm just doing a little at a time to try to keep it lined up. Just like that. Okay, so I'll do the rest of this and get the LCD and the keyboard mounted back in here. By the way, all these keys that go in here are the same, so except for this little one, of course, so no need to worry about keeping those separated. And all the screws that hold the keyboard and the LCD in are all the same as well. Well, we got our top cover reassembled here. I actually had to try a couple times. I kept getting little specks stuck between the LCD and the plastic. But eventually got there, and you might remember when I first pulled out this partially disassembled machine, there was this piece of plastic laying on top of the main board. I didn't remember what it was for, even if it was for this machine. I tried looking in the service manual. It had no parts breakdown. Of course, it didn't mention this. I tried looking at my previous video where I worked on one of these. Didn't see a shot of it. I looked for pictures online, other videos, didn't see anything. So I posted a picture on social media asking anybody if they recognized this part. Somebody posted a picture, which will pop up here, and it goes right here to cover up these connections where these wires are soldered on here. I'm guessing so when these wires fold back like so, they're not folding right on top of those pokey solder joints. And you know, I really thought that this notch had some reason. I was trying to figure out what that fit around, but no, it doesn't mean a thing. It just goes like that. I cleaned off the sticky stuff that was on there, and I'll just put some of this 3M thin double-sided tape on there. I've used this in several other videos. It's good for things like rubber feet and things like that. It kind of replicates the original adhesive that was used. Sticks really well. So I've got the link to that in the description. And just sit there right like that. See if that adhesive will work. Well, that's not working too well. Maybe if we slip it under the gonna go have to plan B. That tape is not sticking to these little pointy parts. So let me go find something else. Okay, for lack of a better idea, I'm going to use some E6000. You've seen me use this on other videos. This is nice because it remains somewhat pliable, and while it sticks good, it's still fairly easy to scrape off if you ever need to redo something. So just put a few dots around there. Bit messy looking, but it'll do the work. I can't speak. So I'll just use some masking tape to kind of hold it in place while the glue sets up. And then we'll move on to other parts of the job. I'm curious if you have any other ideas about how you might have stuck that back down. And what do we do next? We ought to get to that battery. Okay, let's move on to our battery replacement. I had set the battery with this a couple of years ago, I guess, when I started working on it originally. The positive is marked on the board on this side, negative on this side, of course. And notice this has a piece of tape over that area with a hole in the tape where that screw hole is. Kind of curious. So we'll start out with a little fresh solder on that area. I've got a 3/16 chisel tip on the iron. It's about between 4 and 5 millimeters. And I'm just going to heat up the joint from this side, give it a few seconds to soak through. And I kind of pulled on the top of the battery that way to pull it through the board. And I'll do the same thing here. Okay, now here again, I call this wiggling a component out. It's much easier for these batteries than trying to desolder it, because a lot of times they're a tight fit. And this battery, you'll notice, has wire leads. Yeah, like that. Whereas most of these guys have a sort of blade lead like this. And these will work, but you see how the bottom edge of that is flat? I can't center it right here. That's flat. That's so when you set it down in the holes, the battery doesn't want to rock back and forth. And on this particular version of this board, that causes a problem. Let me desolder these holes now before we flip it over and see. So now with the battery out of there, these holes are fairly easy to desolder. You notice on these thicker traces, I'm leaving the iron on there for 3 to 5 seconds. One of the biggest problems when desoldering is you're not letting the solder heat up all the way through the joint, and then things are really difficult to do or to remove. When these go through wave machines, it's in there for many seconds, preheating and then going through the solder wave and then cooling down. So 3 to 5 seconds is not an excessive amount of time. So now for our, oh, you know what? That is not a new battery. That's corroded already. Okay, I'll go get a new battery. It looks just like this though. I may have stuck this in here in order to recycle it. I'll put this other one in there too. Okay, here is a brand new one. Just got these in. I did go ahead and stock these. I use so many myself, and some of the prices online are kind of high, so I decided to stock them. Yep, same width. Now, what happens on this board version, let me zoom in here and I'll show you. You see this is where the battery positive terminal goes in, and there's a pad right there. And we've got the same thing right here, the negative terminal, and there's a pad right there. This wide base on this battery might contact those two areas. It wasn't a really good board layout. There's another version of this board where they move these vias away from the battery lead holes, which made a lot more sense. So what I'm going to do is add a little piece of Kapton tape in here. Yeah, it's hard to see and get it positioned right. Nope, I missed it. What if I just do it like this? Oh, that was much easier. Okay. It really doesn't need to be that long, but it's not going to hurt anything. So all we want to do is keep the battery leg from accidentally touching there. Use a smaller piece this time and do the same thing over here. Oh, that looks much better. Okay, I'm not satisfied with this big honking piece. That looks ugly. Somebody look at that and wonder what the guy that did that was thinking. Okay, there goes my furnace. Okay, there we go. Now we've got some Kapton tape down there so we won't accidentally short that guy out. You might be able to hear the 3D printer going behind me. I found my project files for that extended 1541 project, so I called it. So I am printing a new set of extension pieces to test, because actually when I printed those before, that was with my old printer, and the new printer is much better. So in order to properly test fitment, we'll do it with the new printer and see how everything fits. So I threw in an old roll of filament, since we're just testing, and fired the printer up. The battery, well, the lead on it will suck in a lot of heat which is why I am using this big tip. Bigger tip will transfer more heat. And triple check that we have positive, positive, and negative, negative. And now we have a brand new nickel metal hydride memory backup battery that will probably outlast me. And I guess before we start reassembling, we want to check out that power supply, but first I'll go ahead and put this piece of tape on here. I guess they did that to protect the battery leads. Just like that. Okay. I don't know from what, because there's nothing really under on that part of the board. But anywho, on to the power supply. So I pulled these capacitors up in this area, and you might just be able to see it looks like there's a little ring around here. That might just be the flux. This I cleaned just to see if there's anything damaged underneath it, and there doesn't look like it, but there's a few of them that have little brown specks like this, which might be the indication of the start of a leak. This one also looked maybe slightly bulged on the bottom, so I've got all the caps. They're some of the same ones used for the Model 100, so I'm just going to replace them. Now, when I remove these, I use that same walking method I did for the battery, because a lot of these come through to this big ground plane on the front side of the board, and there's no thermal relief around here, and they are terribly difficult to desolder with a vacuum desoldering tool. So I walk them out of there, and then you have access to the front, and you can put your desoldering iron in from the front where that big copper fill is here. And you can leave it there about 5 seconds, and you'll heat up the copper enough that it'll desolder quite easily. So I'm going to go ahead and swap these capacitors out, and then we can start reassembling. Oh, one other thing I forgot to mention. You might just be able to see there how long some of the leads are on this board. That is a mess. Some of them are bent over. This never should have gotten through quality control. Something was up with the insertion machine, and it was not cutting and bending the leads properly. So after I put the caps in, I'll take a few minutes and trim this whole board down. Okay, now all we have left is putting everything back together. Let's get started. Okay. Set our memory switched off for now. Get our board set in there. Luckily, all these screws are the same length. Makes our job much easier. And remember, just start these guys. Snug them up after we get them all started. It just helps making sure all the holes are nice and aligned. Here we have this guy to contend with. I kind of stacked up the serial port and parallel port. Okay, and go ahead and plug that in. We have our dealy bob here, and we can't forget about Mr. Door. It's for the cartridge port thing. It's got a little spring right here. I'm just going to hold that back with my finger while I set this down. There we go. Just to make sure the spring goes on this side of the flap. And there we go. Now that we've got all the screws studded, we can go ahead and snug them up. Okay, now for the power supply. Go ahead and clean off this face of this thing. Haven't got him cleaned up yet. Okay. Slip him into place. The board slips under here. It's fixed with one screw here. Now you remember, I was missing this screw. I found one in a pile of screws from a inkjet printer that I disassembled. I always like taking apart old stuff like that. A lot of times there's some parts that are handy, the screws are always handy, and it's fun seeing how they make things. Okay, all of that is back together. The little flap here works. Set our screen like this. Keyboard connector 1, keyboard connector 2. And you can see when we fold this over, this clear plastic sheet is preventing the wires here from rubbing right here. And got another connector right there, and of course we want a screen, don't we? Plug the screen in. Okay. That's all fitting together pretty nicely. Now luckily, I had saved the case screws in this little baggie. And yes, these all are the same. So we've got 4 perimeter screws and the 3 that hold this door on. So let's just start the perimeter screws. Oh, you know what? These are the same size. The perimeter screws have a gold colored plating, and these screws do not. They're silver or chrome. I'm lifting up each corner and kind of squeezing it together. Okay, we've got our original ROM module in there. That kind of looks like an EPROM in a fancy plastic box. It's awfully light though for an EPROM. Oh, it's got a metal lid. Okay. We'll pop this open in a bit. Set it aside for now. Okay, and okay, now I put some painter's tape over this paper label to try to save it. I didn't know if it would, but it looks like it did a pretty good job. That's just part of the original history of the machine, so try to keep it on there. And there we go. Alright, now we need to get some power hooked up to it and see what happens. Well, as you can see, it's working great. It's able to write our favorite basic test program. Just print it's Hey Birt to the screen. The LCD looks fine. I've got it kind of adjusted to look good on the camera now. You can go all the way from too light to way too dark. About there is great for me, but that's a little light for the camera. And this is a little dark for me, but it looks great on the camera. Now, I checked those NiCad cells, which I had speculated might be new cells, and they were still over 1.1 volts. So that was pretty good. I checked both of these battery cassettes, and they both have the resistor soldered in here. And I'll put a link to this site below. It's really useful for the 8201. They talk about to convert a regular battery cassette into the NiCad cassette, you solder a 71.5K resistor between these two pads, and that's that. And when you plug in the external power adapter, this guy, which I have tested, it does work fine. When you plug this guy in, it will actually charge the NiCad batteries then too. And the resistor also changes the low voltage trip point for the low battery light here. So both of these cassettes have been set up for NiCads, and right now I am charging the ones that are in here. You can probably hear the bench power supply. I like powering these up first with the bench power supply. I can check the current draw. We're about 51 milliamps right now, which is perfectly fine for this guy with the LCD going, full of RAM, etc. So I think we are good to go. We'll let the backup battery charge some more since it's a new battery. Let the NiCads charge some more. Sometime later, I still need to check out what's on this tape. That's interesting. But I think for now, before we close this video out, we'll have a look what's in this funny plastic EPROM package with the metal lid. So, it's quite light. It's not a regular EPROM. Let's have a look. Okay, let's see what's in this little EPROM thingy. It's Metropolitan Insurance Companies. So some type of program for their stuff. You can see this is an injection molded plastic thing with some pins on it, and it's got this little metal cap, a little thin aluminum cap. So I think I could try to pry this cap up with a utility knife. Trying to get it where we can both see here. There we go. So if I can avoid damaging the metal cap as much as possible, that would be great. But I'm not that attached to an insurance company. Ow! Jam that pin right into my finger. This is... Sorry, you can't see that. This is nothing in this box. There is... What in the world? And it's sealed up. Okay, I'm going to pop this case open and we're going to look in there. I bet we're going to find a diode. That kind of looks like a diode right there. So this is like a dongle. That I have never seen before. Wow. Yes, there we go. So we have pin 14, 13, 12, and 28, 27, 26, 25, 24, 23. Have a diode soldered across them. This is some type of security dongle. Very curious. I have never seen that before. An interesting little package there. So the cover came off pretty cleanly, as you can see there. So I will leave this, the speculation about what this diode does or how it's read, to you guys as like a homework assignment, and just let me know in the comments below what you think this diode did and how that would have been used from software. That'll be kind of interesting. Well, how about that? We got our NEC PC-8201A working and back together, after it sat for a couple years. That's always a problem with a project or repair that gets interrupted. You don't remember where you left off. It's already taken apart. Not sure, if all the parts are still there, if there's extra parts that have migrated their way in. Yeah, that type of thing. And we kind of saw all of that. We started out with a SX64 keyboard cable that obviously didn't go to it. Then there was that clear plastic piece. I had no earthly idea where it went. Luckily, somebody online was able to point me in the right direction there. And we got it back together. I also had that battery, which I thought was a new one because it looked a lot like the new ones that I keep in stock, but in fact it was an old battery that needed to be recycled. So glad I didn't solder that guy in there. But we got there in the end. It's all back together. It's working fine, and I have no idea why it took me so long to finish this up. But it's done now, and we even found this weird dongle thing. I've never seen one of these before, so I'm interested to hear if you guys have. You might hear the 3D printer running in the background. I started printing a new set of case extender parts for that 1541 that's sitting over there. So maybe we'll see that in a future episode. Let me know if you would like to see how that was done. If you have any questions or comments, well, just leave them in that comment section down below. I would love to hear from you. Thanks to everyone who helps support the Hey Birt channel through Patreon and other means. It's greatly appreciated. And until next time, bye.